There is one thing that the IPCC says is essential in how we tackle climate change, but a bunch of people, including some climate scientists and campaigners, are outraged about what it might mean. It's likely to be a real fault line in what happens next, so let's have a look. A couple of weeks ago, there was the third and final part of the latest round of UN climate change reports produced by the Intergovernmental Panel on Climate Change, the IPCC. We're used to seeing these reports come along, lots of headlines about urgency and potential catastrophe and all of that, and to see climate scientists and environmentalists lining up behind them. But the latest one is different. I mean, it generated the usual type of headlines, albeit fewer of them because everyone's kind of focusing on war right now, but it didn't get universal support for everything. Indeed, it got some vigorous kickback from some climate scientists and environmentalists as well. Such as Simon Clarke, for instance, who does an extremely good YouTube channel where he explains some of the science in an accessible way. He just did a video titled "The Rotten Core of the New IPCC Report," which is pretty strong stuff. It's worth noting why this report is substantively different to the previous ones. IPCC reports are summaries of the latest science on climate change. Drawing from many hundreds of studies, they paint the current picture on how we understand what's happening with climate change and why, and then also what the impact of such change currently is and what it's likely to be in the future. But the one that's just come out is different, because this one reflects on what are the policy options, the technologies and the approaches needed if the world is to achieve its stated goal of keeping warming below certain set levels. The first two, what's happening, what will be the impact, those are firmly within the wheelhouse of climate and related scientists. This report covers areas that one might be inclined to look more carefully, because lots of people have different ideas on what should be done, and many of them bring assumptions to that table that can be influenced by people's politics or by their values or their prior preferences. So, for instance, the report has this graph, which tries to map out how much impact different policy areas could have on climate change and how expensive would they be and to what extent. If there's some cost-effective action that can be taken, well, that's coloured blue, and then at some point maybe that starts to go red as you get to the areas that are more expensive, arguably less good value for money. Now, that's very interesting, very compelling, but such assessments, unlike the other things that the IPCC does, do not draw logically from the laws of physics. I would want to study the detail of the methodology that underpins that particularly important graph, because we know that, for instance, technologies pushed to scale become cheaper. We know that new technologies pushed to scale tend to improve and become more effective. Climate scientists and environmentalists would be the first to trumpet that process for renewables, solar, wind power. And they'd be correct to do so. Thanks to early support, those technologies have been pushed to greater scale. They're now getting more efficient than they were, and they are certainly cheaper than they were. So how do you allow for that sort of process in your evaluation here? There are some technologies that some people like and other people that, for different reasons, hold to be controversial. One of my starting questions would be, are they being treated in a coherent way, and how would we know? Also, when different energy sources have pros and cons that need to be balanced against each other, does it even benefit us to look at something like this, since it can't capture those pros and cons? It's only measuring two things. Well, generally the IPCC reports all the data and methodologies available, so let's take a look. And that's when you find this. Underlying data for the SPM figures will be published on this webpage. Please check back shortly. This figure has been promoted significantly, so that's not an entirely satisfactory situation. This isn't, however, what Simon Clarke and others were upset about. It was in the discussion of one aspect of all of this, carbon capture and storage, CCS. Here's the paragraph from section C4, subsection 4. Limiting global warming to 2 degrees C or below will leave a substantial amount of fossil fuels unburnt. Depending on its availability, CCS could allow fossil fuels to be used longer, reducing stranded assets (high confidence). The mere floating of that as a possibility was enough to blow a number of gaskets, in a way that goes beyond any sort of practical assessment of how likely something is to be possible into the field of morality and values. And it rather outlines what I think is going to be that major fault line running through the climate transition in the coming decade. So we'll come to that. But first let's start with the practicalities, because what are these people arguing about and why does it even matter? You'll be familiar by now with the term net zero, the idea we aim to transition our economy so that we can produce the things we want without producing greenhouse gas emissions. But it's net zero, not absolute zero, because some things are going to be almost impossible, certainly in short time frames, to bring to zero emissions. Air travel, for instance. Environmentalists may hold that people should simply fly less, but all but the most extreme don't suggest that people shouldn't fly at all, and indeed they often fly plenty themselves. Well, electrifying planes is extremely difficult. The weight of a battery would make it pretty much impossible. So there will be some sectors like that, although they could be made more efficient and there could be some fuel innovation, then basically you need to remove some emissions from the atmosphere so you can make up for the ones that you can't avoid adding. So far so straightforward, and there have been some various scientists over the last decade that have talked about the urgency in improving carbon removal technologies so that they can pull their weight as the process moves forward. A lot of that focuses on removing carbon from emissions at the source. That's a way of making certain current fuel sources less polluting. You can see in this graph it's only about a third of the total in captured emissions that comes from processes that actually remove carbon from the air. But it's an important third. In its 2018 report, the IPCC said that pathways to limit global warming to 1.5 degrees C project carbon dioxide removal from the atmosphere in the order of 100 to 1,000 gigatons over the course of the 21st century. In this paper, published in the journal Nature Climate Change, researchers highlighted that lack of investment in carbon capture and storage technology is putting progress on keeping warming down in jeopardy. So everyone's a fan then? Well, it depends. Let's not get ahead of ourselves. There are two principal ways to go about removing CO2 from the atmosphere. First, natural solutions. Second, technological ones. You can probably identify immediately at least one of the natural solutions because we hear about it rather a lot. Yes, it's planting trees. Planting trees is a good thing to do. The planet has been deforested quite significantly in the course of human development. But when you push it to scale, as with most things, it doesn't come cost-free. The IPCC calculated that around 500 million hectares of previously forested and currently unused land could be available and suitable for reforestation without necessarily impacting food or biodiversity. Obviously, if you convert agricultural land to forest, it's not a great thing to do as we prepare to feed probably around about 10 billion people in the next few decades. And likewise, we don't want to make large numbers of species extinct by converting currently rich habitats into plantation forests, so 500 million hectares. That is still a lot of land. If you successfully planted it all, studies have suggested that, depending on it being done properly, it could remove 3,700 million tonnes of carbon per year. Certainly a substantial contribution. If strategically matched against the hard to decarbonise sectors it would be anyway. How strategic it will actually be is another question. Shell Oil Company, which has announced ambitious targets for bringing its net emissions down, has proposed that it alone will plant 50 million hectares of trees. That is 1/10 of the total land thought to be available. For context, it's an area the size of Spain. Just one company. But then it's not just one company. The oil company Eni is planning to plant up to 30 million hectares, which is about the size of Italy. And the same again for the firm that owns British Airways. So you could stitch the UK and Switzerland together for that one. All of that is well and good, of course. But the fossil fuels being burnt, they were underground and secure throughout history. Forests, they've been known to catch fire. Sometimes political changes happen and they end up getting burned down deliberately. And when that happens, obviously, all of that embedded carbon gets shoved straight back into the atmosphere. So then there's another possibility, which is labelled as BECCS, bioenergy with carbon capture and storage. The short version is that you grow the trees which take up carbon, you then burn the trees as a fuel to produce energy, and as you do so you capture the carbon that would otherwise have been released to the atmosphere. You can then bury that deep underground where it will never trouble anyone again. That's the theory. It's somewhat controversial. Some think it's the best solution. The UK Drax power station now burns biofuel with carbon capture, and it looks at the UK's recent net zero strategy, which aims for 5 million tonnes of negative emissions by 2030, and it believes that its operations are the cheapest way to get to that sort of scale. There are a lot of people sceptical about whether that's truly a model that has a huge amount of promise. On the energy side, growing trees and burning them is the lowest power density form of energy you're going to get. In other words, it takes an enormous amount of land per gigawatt of energy produced, the least efficient method we have in that sense. Fossil fuels have negative impacts, which means we do have to move beyond them. But let's not forget, they revolutionised human well-being by being an incredibly power-dense and portable energy source. We can certainly trade some of that advantage for energy sources that don't have its downsides, but I don't see how you could expect to make real progress in a modern transition by using vast amounts of land to grow wood to burn. And the natural approach, taking vast tracts of land and planting on them, there's some benefit to be had, but if done in the wrong way, it can have unintended consequences all of its own. The second of the three latest IPCC reports said this: the most serious emerging conflicts are between land-based approaches to mitigation and the protection of biodiversity. For all that climate campaigners go on about climate change and the projected sixth mass extinction, so far the evidence is that the overwhelming majority of species loss is tied to habitat loss. And that's kind of good news, because it means that if you restore the habitat, which we do know how to do, then you see the return of that biodiversity very often. But if instead you establish large plantations of fast-growing trees, rather than supporting a long-term natural environment that is potentially running counter to what you're trying to achieve. There's a better business model for the plantations, of course, but according to one study in the journal Nature, natural forests store 6 times more carbon than agroforestry and 40 times more than plantations. So what about the second category, the carbon removal technology? What's happening there? We're seeing the development of technology for what's called direct air carbon capture, or DACS. And it works. You get large plants that suck in the air and then filters that capture the CO2, converting it into a form that can be used or disposed. Right now, it's early days for the technology, so you would expect the earliest versions to not be as effective as they need to be and the prices to be high. You'd be correct to expect that. DACS is currently very energy intensive, and that leads it to be expensive, around $600 to $1,000 per tonne of CO2. There are 15 DACS plants operating worldwide. They currently capture just 10 kilotons of carbon per year, which is barely a spit in a bucket, if you'll excuse the colourful analogy. The energy use is huge. If you were to scale DACS up to remove 10 gigatons of CO2 per year, which is in line with the carbon removal envisaged in many of the models for the latter half of the century, they would require energy equivalent to 7 to 17% of current global energy demand. But that is due to change with improved technology and with bigger plants. Right now, there are 3 companies involved in pushing this: Climeworks from Switzerland, Carbon Engineering in British Columbia, and Global Thermostat in the United States. Some of the major oil corporations and others are looking to heavily invest in the area, and they are widely seen as the ones with the experience and the infrastructure to push things like carbon storage to scale. For those companies looking to find ways to be a part of future solutions, not just the old ones, it could be a part of how they navigate a major energy transition. So, for instance, Carbon Engineering is partnering with Occidental on a commercial facility in the Permian Basin. When it becomes operational in 2024, it will be able to capture around 1 million tonnes of CO2 per year, which is a major increase in scale, equivalent to about 40 million trees, obviously taking a lot less land. Investors certainly seem to be optimistic this will come good as one of the important technologies of the future. So Clearbridge, for example, did a recent white paper on the topic saying this: in fact, though the technology is in the early stages, carbon capture is likely being underestimated in its importance and scalability over the next 30 years. That doesn't make it guaranteed, of course, and investors sometimes make bad calls and lose money as a result. But reasonable, hard-nosed people, not greenies, think that this could scale and become an important part of the mix. In fact, a significant proportion of greenies actually hate the idea. Not that they think it won't work, they fear it might. We'll come to that in a moment. In the short term, there are some counter notes to how this plays out in the short term. Because these early plants are mostly not capturing carbon and storing it, they're capturing carbon and then using it. In the longer run, that might be no bad thing. So CO2 may be used, for instance, in the production of synthetic fuels that could be used in aviation. Aviation is nigh on impossible to switch to zero emissions, but if it's using that energy-dense fuel that emits carbon, but that was originally derived from carbon that was sucked out of the atmosphere in the first place, you could see how that industry might become carbon neutral. Right now, that's not exactly what we're talking about, though. Oil companies have found that CO2 can be injected into depleting oil fields in a way that makes the extraction of the oil more efficient, something that's called enhanced oil recovery. And right now, some of the CO2 from these operations is going into that practice. You can see why that wouldn't impress everyone as an outcome. But the challenge for all of this is that there needs to be a business model. Sucking carbon out of the air and burying it is great, but who pays for that? And on what basis? I suppose a government might do so long as someone's in charge who values that outcome, but really you want the process to feed into a value-added product that people will actually pay for. The aviation fuel, when it's matured into practical reality, costs have come down to make it viable, that could easily be part of that. Burying it could be something that companies buy as part of a carbon offsetting program. They're required to be net zero, and the ones that can't get to zero therefore buy credits based on carbon being buried on their behalf. I mean, at least that would be more substantial than what passes for carbon credits at the moment, which are often pretty much worthy of the word scam in the sleight of hand used, double counting, claiming trees that already existed anyway, and so on and so on. So far, out of those three companies, only Climeworks has the technology to store carbon permanently underground. The other two plan to reformat the gas into hydrocarbons that can be burnt as fuel. So we need to improve the technology. We need to push it to scale. It seems likely that some of the biggest and the most powerful companies in the world are motivated to do exactly that. There are clearly big practical problems to be solved, but we're a problem-solving species, so let's crack on about it. So, remind me again, why are so many climate scientists and others upset about this? The thing that draws their ire is the suspicion that others are eyeing another prize. That if the tech could be pushed even more aggressively to scale, it might mean we could actually continue at some level at least to continue to exploit fossil fuels. As flagged by that paragraph in the IPCC report, this could potentially mean that some of the assets currently invested in oil and gas might continue to be of value. Now, some scepticism, you might even say a lot of scepticism, is due to that proposition, given the enormous scale that would be required. But since the companies that might eye that ambition are used to operating at scale, if they think it can be done, why not? If it means that they're going to invest more aggressively in technology we said we already need. But if you look at the responses to this, it's not practical skepticism. It's more akin to moral outrage, and it's rather interesting. So let's go back to Simon Clarke. His initial response was to say, no way, the potential impact of carbon capture is too small, the cost is way too high. Which sounds like a pragmatic objection, although it seems to presume that impact can't go up with investment and cost can't come down. It's not the sort of objection that gets you naming your video the rotten core at the heart of the IPCC report. And indeed, he went on to argue that carbon capture and storage is prominent because corporations lobby governments, and that focusing on it would obfuscate meaningful action. Which is the language that says these corporations aren't potential partners innovating new technology we need, they're scoundrels trying to get away with something. And that something, of course, is creating the circumstances where we could continue to use oil, at least at some level. The argument was given explicit voice by the US energy correspondent of the Financial Times, Miles McCormick, who said this: the key problem with carbon capture, as many environmentalists see it, is that fossil fuels producers can continue to operate as they are operating now without having to overhaul the way they do things, because any emissions that are produced can just be sucked back up. I repeat, there is a pragmatic objection to this happening, which is that you're unlikely to reach the sort of scale you'd need to cover the emissions that can't be reduced any other way. So to do that, plus the optional ones that would be profitable for oil companies to carry on as before, very unlikely. In that situation, you should reduce all the emissions you can by switching energy sources and then basically just cover the emissions that are unavoidable. But that's a practical question. And getting better carbon capture technology at larger scale will always give you more options, you would think. But for many, it isn't a practical question, it's a moral one. One environmentalist put it like this: in our world, there shouldn't be a Shell or a BP or an Exxon or Russian oligarchs. What are they doing there? Or etc., etc. And there's no excuse for insisting we shouldn't end these institutions. The planet is dying and we're running out of time. The companies must be disbanded. The CEOs and leaders must be tried by the law. The money of these companies has to be democratically invested into the switch from fossil fuels to sustainable, eco-friendly energy. That is clearly the solution. Is it though? There is a history of ideologically driven governments seizing the assets of large corporations to further their own objectives, and it doesn't have a stellar track record. Redistributing wealth does not create wealth, so everyone ends up a lot poorer and inclined to throw out the government that got them that way. But this is a point. They don't want a future that looks like today. Regardless of how big a crisis they think we're in, they won't settle for anything that doesn't pass their purity test. And that means the solutions mustn't benefit oil companies, because they've decided they're uniquely morally culpable, even though they kind of just provided the products that we demanded of them, and the societal benefits of those products have been significant. Yes, those companies have some things to answer for, but shutting BP and Shell down won't stop China from building the 100 new coal-fired power plants that they're building. You need the innovation more than you need revenge against executives who have mostly since retired anyway. But political people are committed to us versus them. So there was this tweet from Democratic Representative Ayanna Pressley. Big Oil keeps touting carbon capture and other dangerous and unproven technologies to avoid doing what's really necessary, reducing oil and gas production. Let's call it as it is, a delay tactic and a distraction. So in the hands of the politically motivated, the practical problems and the genuine dilemmas that we've been discussing get simplified to the concept of dangerous, how, and unproven, which is arguable. But that's a reason not to put all your eggs in one basket, rather than actually labelling something that the IPCC says is necessary as being purely a vehicle for big oil. Now please note, I am not arguing for or against any specific approach to carbon capture and storage. I don't champion one technology over another. I'm interested in what's happening, who's pushing which way, what it might mean. And I've said plenty in this video about the challenges to be overcome with all of this. I am simply noting, right now, this area is not being addressed wholly pragmatically. There's certainly motivated reasoning by the businesses, a degree of wishful thinking maybe, or invention born of necessity. We will only know after the event. But that's fine. If they invest and it doesn't come good, they lose. But if they don't invest, and we don't make the progress that scientists say that we need to make, I'm struggling to see how that helps. It sounds like people want investment in these technologies so long as nobody we don't like does it, and therefore becomes successful. And that's why I would really like to see the data and the process behind that IPCC calculation on the most effective actions to mitigate climate change. This is an area where values and opinions can very easily be mistaken for impartiality. And with government starting to take action, we're going to see a much sharper fight over the different visions of how this should be done. It's as well to be ready for it. By the way, sometimes when I do videos on this topic, some people, because of where our political discourse has been, will ask, do we really need to do any of all this? Is it really the case that climate change is human-caused in the first place? Well, yes. Not everything that the extreme campaigners say on the topic is as well grounded in the science as they would have you think, but the evidence on that core proposition is pretty compelling. If you're asking that question, you might be interested in this video, where I look in detail at precisely that evidence.